Okay, starting recording. Cool, so in the meeting notes, first draft of user experiences.
Yeah, I started to put all the pieces together about all the three main issues or announcement that we are talking about: self-hosting, HA, and upgrades. And it was somehow difficult to understand what will be the final user experience of Kubernetes admin at the end of this journey. So I tried to put together some notes. Now I share. So
this looks really good. This is like incredibly detailed and looks fantastic.
Okay, let's go to the proper windows. Just a sec. Okay. Yeah. So the first thing that came out to me is then, okay, Kubernetes is moving to support different type of deployments. So we are going to support single node deployment, single master, which is what is already there, but also multi-master. Okay, and this is easy. Then, okay, this is the easy part, but what is in scope of what we are going to document or what is managed by kubadmin is not so clear. For instance, for the multi-master, there is we need a API server load balancer, I do expect. I'm not sure if this will be in scope or not. Might be not. The second part is that we are already supporting different deployment options for components. For instance, the control plane, we are supporting the deployment with a static manifest and also with self-hosted, where we have to join to add the control plane recovery, checkpointing. There was a long discussion about the name. And the same goes for etcd, where for sure now we are supporting static manifest, but I'm guessing that we are going to support also the etc operator.
Yeah. So if I just have some comments so far, and hi Aaron, I'm glad you could join us. So I think that this presentation as it stands is a bit ambitious in terms of 1.8. My understanding is that we are not actually targeting HA in 1.8. It will probably be more like 1.9. But I may be wrong, and it may be that the work proceeds faster than we expect. My ambition was to just support self-hosted upgrades with a single master in time for 1.8. But I've also not been in all of these meetings, so I may be behind on the consensus.
Yes, this was the original question. I don't know, because at the end, then thinking, many points come up to me, and I don't know if the meeting, this was all the meeting, and we have here Aaron that can give us an update on the etc operator. So maybe that is better that people comment on the document offline. I give you just a brief overview of what the document contains.
Yeah, please. It looks really good. So yeah, please go through it.
Okay, so the second point that comes up to me is that we will support, I guess, different type of upgrades. The first one is the easiest one, the release upgrade. So from version X to version Y. is quite and
again, y equals 6 in this example.
R?
Oh no, sorry. This is covering. I was asking whether y equals 6 in this slide, or
equals 6 where?
Sorry, in the heading where you say from 1.6.x to 1.y dot z.
Because maybe that you go from 1.6.x to 1.6.y.
Mm-hmm.
Or you move the measure release. So you do an upgrade of minor, of major, and so on. So those was the scenario that I guess they are supporting. And,
yeah.
and the idea is, okay, but we are supporting upgrade for all these matrix, at least those. This is something that for me it is interesting to understand. But another point is that we are going, or we already support another kind of upgrade, which is I call it the deployment of option upgrade. So we move from static manifest to self-hosted. That is something that we can do already now in the head of the codes. And the last type of upgrade is that, okay, I move from single node to single master with some workers and so on. So, and those was scenario that for me are nearly there. So it's interesting if to understand if we are going to support officially. So it's something that we have to plan to test and whatever. And the last part, which is really draft, is starting to, I started to draft use case by use case the user experience. So install prerequisite, apt get and whatever, kubeadmin init, and then I need to taint the master and install networking, or vice versa, the master. The one master and node, so where basically I do init and then after networking do join. Or the most interesting here is what will be the experience for HA. Here, at least there are two scenarios. The option one is that where I do init, in the first master, this master get self-hosted. Most probably, I need also the ACT operator here, and then I add the secondary master and then other worker nodes. This is one option. The other option is a little bit different, but from my point of view, is easiest to implement. Because before you do in the first master, you do init. Then on the first master, you install networking. So you get a working master and without the problem of the node ready issue, which is annoying many people in the SIG. And then you can join nodes as a secondary master, so candidate masters. And only at this point, when you have three master joined with the networking, you upgrade the control plane doing self-hosting and installing the etc operator by knowing the node that where etcd have to be installed. This and after that you can join. So that's it. If possible, I kindly ask people to comment on this.
So my feedback is just that this looks like a fantastic document. I'm glad that you're thinking about this. I think that the end state that you're describing here is not what we will get to in 1.8 most likely, but I think that it's good to try and hash out what these options are and what the details are of them. And that's the last I'll say. I'm really interested in knowing what everyone else on the call thinks.
Yeah, I agree. It seems a little bit ambitious for 1.8, but it seems like it's pointing in the right direction.
Okay, thank you.
I'll definitely take a closer look and add some comments on your spreadsheet also.
Thank you very much. Very appreciated. Okay. So I let the floor to Aaron, I guess.
Yeah, Aaron, did you have any thoughts on what Fabrizio was presenting?
I think I jumped in middle of the presentation, but I like the diagram, like the single versus master and the options there. That actually looks pretty good because the single master kind of brings up some problematic questions about how we support this stuff. So I'll take a deeper look at that document and add some comments there too.
Cool, sounds good. And Tim said he was going to join around now.
Okay. I'm not sure there's any overlap between last Friday's call and people that are here today, but I did watch last Friday's meeting, and there was a lot of discussion about whether we wanted to, we definitely need to support upgrades of single node masters also, and whether that should be supported through a self-hosted mechanism or not. And so I think we need to figure out what single master cluster upgrade looks like. And it's fine if it's static manifest and kind of what we did for 1.7, you run a kubeadmin init command and it swaps around manifest files. I think that's perfectly reasonable, as opposed to using kubectl to update your control plane in a self-hosted manner. And say if you want the self-hosted control plane, you need an HA control plane.
Yeah, I was kind of hoping that we'd be able to figure out how to upgrade single master self-hosted clusters. And I'd like to understand what the issues are so that we can see if we can figure out how to solve them.
So one issue was that the discussion last week had basically ended with running things like the scheduler and the controller manager as daemon sets. And if you're running a daemon set on a single node master, there's really not a good way to upgrade that. I think Aaron had pointed out during the meeting on Tuesday that that's the reason they use deployments for those, is then you could end up with 2 copies of the same binary on the same machine during that upgrade process.
So the whole purpose of daemon sets, now that I'm back, sorry, I sent emails, but no one was, I don't know if people got the emails or not. But the purpose of daemon sets was primarily for high availability. The notion of self-hosting without high availability, I think, is suspect at best. And we commented about that last week too. Like there's this weird thing of having a self-hosted non-HA control plane, which I think is kind of awkward. It allows, the only benefit it gives you is like one thing, which is like easier-ish upgrades. And we kind of agreed that, there's this circle of features, and where the crossover makes more sense is when you have the entire HA/self-hosted. But is there an upgrade issue with daemon sets in the highly available environment?
Well, if I can actually, before people answer that question, if I can just respond on the other pieces you said. We've been talking about this for a while, and like when we spoke about it in November last year, in Seattle, for example, the plan of action at the time was that we were going to do self-hosting, and then we were going to do upgrades, and then we were going to do HA in that order. And so I had always assumed that there was going to be a way of doing upgrades of a single master self-hosted cluster. And I think we worked through some of the details, but we really haven't actually got around to trying to implement it until now. And so, Tim, you're one of the people actually doing the work, and thank you for doing that. And Lucas, who unfortunately isn't here today, is another one of those people, and hopefully others will help out as well. If I just want to try and really get to the bottom of whether like self-hosted upgrades of a single master are just a non-starter, because if they are, then I think we probably need to figure out a different ordering of the features.
You can, but it's an extra step, right? in the puzzle, right? Because there's three checklists of features, and they all kind of interleave, right? And we have two of the checklists, and we don't have the upgrade checklist kind of all complete, right? So we have a checklist for HA, we have a checklist for self-hosting, and the upgrade one is not all there. So we're starting down the road of self-hosting first, right? And I know Lucas started with some of his PRs specifically with daemon sets in mind, but we haven't. There's some other issues that we were going to talk about this week, namely the manifest checkpointer, which I like to call it now, versus like an actual checkpointer. So I don't think it's a strict layering. That's my problem, right? Like I think there's this weird intermingling that will exist for a while, and I wouldn't really recommend self-hosted upgrades, honestly, for a single master.
I mean, I can at least speak to some of our reasoning and our process for this. So one reason was we wanted the same path for, I'm going to spin up a single node cluster, and now I'm going to expand it to a multi-master cluster, and that's the exact same installation path. So it wasn't, oh, I selected single master and I was doing work against it, and now I don't have a path forward. So that was a big one, not just I know what I'm selecting out the gate. And then also, this is kind of a little bit predicated on, like, the reason for daemon sets, using daemon sets exclusively, is predicated on kind of a behavioral issue that may actually change, which is that they ignore scheduling mechanics, like things like node unready. But there's already open issues talking about having the scheduler actually schedule daemon set pods. And so if we're kind of relying on this behavior, that behavior may even change anyway. I'm not opposed to daemon sets. It kind of matches a lot of like what we want, which is these components running on master nodes. If you had a whole bunch of master nodes, it might be inefficient, but yeah. So, I mean, for us, it was worth it to switch to using deployments so that we could support single master upgrades and single master expansion, essentially. And it works. It's just, we have to figure out the behavior from kubeadmin's side. The issue right now is essentially that networking isn't installed automatically. It's like this follow-up step. And so stuff is just sitting there, which maybe that's just something that needs to change. Like you have to pre-select that networking needs to happen as part of the initial phase.
I would be open to that. I mean, even if you have to pass a URL to some YAML file for like a networking, a CNI provider into kubeadmin, or it has some presets, like I've always been open to that. I don't think it's a big deal.
So like the static scheduler and controller manager just don't go away until networking shows up. Now your control plane is essentially complete, if we want to think of that way.
So there was examples that people had shown, or ideas that people had bantered about, one of which was that they'd have like a configuration, they'd modify the configuration file so that it mentioned how the control plane would be established, and then you'd pass that around as part of your initialization for starting up. So if you had one node, you could pre-configure your network with your configuration, and you could also pre-configure what to expect. What's the expected end state? It's almost like you're providing a declarative of what the end state should look like, right? I don't know if people had thoughts on that at all or not. I know that there are, I don't know what the issue is with logistics of upgrading in daemon sets. I know I walked into the middle of a conversation, but I didn't hear what the problem was.
So, I mean, essentially it's that different from deployments where you're kind of expanding the number of pods and then contracting it. So if you have one copy, you're creating two and then deleting the old one. With daemon sets, it's remove that one copy and then create a replacement. But let's say that you're upgrading the controller manager, you have one copy running, and then you delete it, and then there's no controller manager to break down the controller manager itself into a new pod. And so you just kind of, bricked your cluster. It's recoverable, but it's just sitting there not doing anything.
For the controller manager for HA configurations, it's not bad. I
For
mean,
HA, it's fine. This is single master. This is exclusive.
Even with single master, it's going to recover for controller manager and scheduler.
Well, if you, let's say that you have a controller manager deployed as a daemon set. So there's a single pod running, you have a single master, and then you upgrade that. So it's going to do a rolling update of that daemon set now. Its behavior, its first step is to delete that controller manager. And now there is nothing that actually creates the new controller manager.
And I thought that I thought the solution that we talked about to this was that you run two of them on the same machine.
So that's what we do in deployments. We just say you must have, like, the minimum number is 2, essentially. With daemon sets, you would have to run 2 daemon sets, which was discussed, and internally, and I'm not a big fan of that because it's just a huge amount of overhead and complexity to kind of work around behavioral issues.
Yeah, I still cringe at the single host or the single master self-hosted. It boggles me in many ways because it's a corner condition that causes a bunch of weird behavioral things that you have to take into account versus just going with manifests. Now, I understand the upgrade constraint, right? Because you want to have a unified way of upgrading from a single, but you could abstract that away, right?
I actually wouldn't call it a corner case. And the reason that I say that is that, as Aaron said, it can be part of the way that you spin up a multi-node cluster in the beginning, like you go through that state. But also, plenty of people, like I speak to a lot of people who are using kubeadm, they're using it with single masters. They might just be happy with that. Or there may be lots and lots of development use cases where it's really important for people to upgrade a single node Kubernetes cluster that they're running on their laptop.
To be clear, my corner case was self-hosted single master, not single master itself.
Yeah, and my concern just about that is that I don't want to have 2 paths. I want to have one recommended path, which is the same whether you're running single master or multi-master, and upgrades should be the same in both cases. Ideally, I think, and I'm just thinking about this from a user experience perspective. Like, that's my primary worry.
But sorry, if we work on the idea of Lucas to install the networking before doing self-hosting, so declaring your network provider, then you can use deployment instead of daemon sets. And so you can do an upgrade that don't get you stuck. I'm right?
I
think so.
I think so. I think that it would be a small price to pay. Like, it's not even a price. Like, I think it's a feature to say, like, install this network in kubeadmin.
I mean, another option, if the only reason not to use daemon sets is the upgrade behavior, we can ask SIG-apps to add a field to specify a different type of upgrade behavior, because there are likely other daemon sets that are better behaved if you.
Oh, sorry, Robert, you just muted yourself.
There are likely other, job types that work better if they're created before deleted anyway. I'm not sure that's going to be a unique consideration here. So that's another avenue we have. If that's the only thing saying that is making us say that daemon sets is a bad idea.
Yeah, that would be a really good option. That would be kind of nice.
Is someone taking notes here?
No, I'm not taking notes, but I am recording the meeting. So it'll be on YouTube.
Well, I just wanted to record that last bit, or at least keep it for posterity.
Yeah, please do. Please make notes in the meeting doc as usual. The other thing, sort of overall, like take a step back, comment is that I kind of just want to say that I feel like Aaron and CoreOS have already figured out how to do this, and we should maybe just listen to their way of doing it and do it their way.
Well, I mean, so all of these discussions, some of them we still have internally. So the daemon set, like, again, it kind of makes sense in a way where you're like, these are the components that I always want to be running on, X number of masters that I have. So if we're in a deployment and we say there's only 2 running and then you expand to 5 masters, something has to, expand that to 5, whereas a daemon set just naturally would. So there's part of that that makes sense. In some cases, if you had 50 masters, I don't know why you would, but you actually probably wouldn't want to be doing that. So this is open-ended, but as Robert said, if we had a different kind of upgrade strategy, this might become more tenable, where we create a new pod rather than just kind of replace the one in place. So that I think is open. I don't think there's like a fixed right answer here. We've gone with the deployment route right now because that's kind of what works today without any new changes. And then, there's some difficulties there, but it essentially, it works. The one thing I wanted to point out, and because I've seen this discussed and can be a little bit confusing, is we don't actually checkpoint the scheduler or the controller manager. We only checkpoint the API server and etcd if it's self-hosted. The reason for this is that our behavior of the checkpointer, which is something else I think we need to discuss, like what the scope is and what we want to do, is that it actually implements garbage collection. So it essentially says if the parent pod that I was checkpointing no longer is scheduled to my local node, I should clean up all of those checkpoints. So it doesn't actually help us in the single master case if we checkpointed the scheduler, controller, manager in a daemon set, because if they're deleted, which is accurate, that pod has been removed, the checkpointer then garbage collects those local checkpoints, because this is more in line in my mind with how the kubelet would actually behave, where if there is no longer a parent that's supposed to be running on that node, then a checkpoint shouldn't exist there. But that is fuzzy in terms of we could change that behavior in terms of kube admin. It just wasn't it wasn't behavior that we particularly wanted initially.
We're also we're not locked into any implementation, right? You could imagine when upgrading from 1.8 to 1.9, if we had chosen to use daemon sets, we could switch to deployments or vice versa, right? So, there may be some benefit to doing what is prudent and works today. And, we're not locked into that forever. And it sounds like that's sort of what CoreOS did, right? They used deployments because that worked today for their use cases, which included single node self-hosted. But that doesn't prevent them from switching to daemon sets if the behavior changed in the future.
From just gauging the amount of work, like adding new upgrade strategies, is that something that is potentially reasonable in the 1.8 timeframe, or is that a pretty heavy change?
I would guess that it wouldn't be that difficult. I mean, it's the order, right? Do you create then delete, or do you delete then create? So I think if that's something we want to ask for, we should ask for it now before other SIGs and teams sort of lock in what they're working on.
Right.
If we think that's a requirement for us to move forward, we should ask for it right away.
I mean, as to your point, like some daemon set cases, that does kind of make more sense.
Yeah.
What I would say I want to argue for is that from a requirements perspective, that we say that a single user experience for single and multi-master upgrades is a requirement, rather than having to sort of fork the path early on and say, oh, I know I want a single master cluster now, and I will always want a single master cluster in the future, versus I might want to expand and add masters later. And I think that sort of product requirement takes us down the self-host everything path, and I think that means that we need to figure out upgrading self-hosted single masters. That's just my read. What do people think?
I think it's a bit of a constraining requirement, but I don't disagree with the idea, right? Like I just think that the self-hosted single master puts more constraints on the order of behavior that you would have if you didn't have that constraint. Now, if you didn't have it, I mean, that the whole reason why you need checkpointing is if you had a single master, so that is self-hosted, right? That it forces checkpointing. You have to have it. Like otherwise your reboot cycle and you're toast, right? I'm not opposed to it, but we just have to, I think what we need to do is come up with the order of how we want it to behave, and that will flush out the checklist of execution.
That seems reasonable. Yeah, and I guess I'm coming from it very much from a user experience. Like, what commands do you type? Like Fabrizio's diagram, maybe we should spend some time to write up what we think the user would have to type in order to achieve things, and then evaluate it and say, is this good enough? Do we force the user to make a decision about single master versus multi-master early on? Are we okay with that? That sort of thing.
So I guess this seems like it's still something that needs to be kind of fleshed out, of whether we support single master or not, and then whether it's supporting daemon sets or not. But the two things would, in my mind, would be if we were able to get a different upgrade strategy, that would kind of just default into daemon sets would just work, and the behavior wouldn't have to change in kubeadmin. If not, then it would just come down to whether or not you want to support single masters, which I lean towards yes, but yeah.
I think we have to. I mean, I think that the dev use case for kubeadmin is massive. I wouldn't be surprised if in the world we end up with more dev kubeadmin clusters than prod kubeadmin clusters. And therefore it's definitely not a corner case. And I get scared whenever we hear things like, oh, the dev cluster will work differently to the prod cluster. I'd love it if they work in the same way, because I think it means that everyone who's developing Kubernetes will use dev clusters which work in the same way as the prod clusters, and you'll end up less likely having bugs in the prod clusters that weren't tested by the developers, if that makes sense.
Well, I don't think that it's necessarily, I don't know if a call can be made now, but one thing I do want to discuss before we get off this is plans for around checkpointing, if we can, at some point.
Yeah, please, go for it.
So part of this is like, what are the requirements from kubeadmin side? And then is it possible that we all work on the same thing, or is it something where we kind of need to fork behaviors and work on different things? One of my colleagues, Diego, was...
Oh, hey.
Yeah, sorry, I can't push my laptop hard enough.
Okay. We've got a few people here.
Yeah, Eric's here as well.
Hello.
So, one thing we were thinking about was just moving it out of BootKube and into an incubator project, just to kind of decouple its lifecycle from BootKube itself, if it's in fact generally useful. But there may be like scope changes, there may be things like changing the annotations from CoreOS specific. So wanted to discuss that and the needs of kubeadmin, and maybe Tim's thoughts now that you've had a chance to dig into it. And then kind of rolling further into that, Eric has some valid concerns about how this functions in terms of auth. There are some pretty important considerations. And then also, I want to still float the idea of us actually doing this in the kubelet and not in an external process altogether.
So I thought, I even have notes where I said that to myself. The one benefit of having an external to the kubelet is that you can version it independently, especially if it's a somehow container, and that could be your single manifest bootstrapping startup thing, right? The one thing that struck me was that you are also checkpointing secrets, right? And that's because of your how you're storing certs, right? Which goes back into, there's a whole bunch of chicken and egg problems, and this is one of them, right? Was where exactly are we going to store the certs for a self-hosted cluster? Because there's security questions and constraints about storing them in the kube system namespace, right? And if you don't have those certs on startup for self-hosted control plane, this is one of the constraints. You know, we'll start to dig into this. If you don't have those certs available as a checkpoint, you're toast, right? So this is why I was bristling a little bit earlier, right? Because there's a bunch of interesting constraints that occur, right? I don't know if Eric has thought about this a bit more, whether or not he thought about the CDR case, or you know, if you have a double secret namespace that you know this other no one else can see, but like this one thing. Have there been any more talks on SIG-auth?
There's not been any specific talks around this this particular use case, but yeah, I think that the main concern was the number of things that try to read from kube system. There was also just like, I think that there was also, so in terms of writing the secrets to disk, in terms of the kubelet and its approval process, it already writes its own certificates to disk, even if you use the CSR endpoint. I think, you know, the awkward alternatives like using a system namespace or a kube secret namespace would be fine. I think that there were also just elevated concerns around where the approver or the signing cert's going to live. Specifically, when you do the CSR endpoints, the controller manager has those signing certs, and it seemed like a lot of the concerns that was raised by other people were around those rather than specific certificates that like the API server would be using to serve traffic. So trying to you know, make sure that we're not having different arguments around that, like providing alternatives where you can run the signer external from the cluster or something like that. A part of this too, the reason why I think it would be difficult to get the checkpointer into the kubelet with its current way it does it is that it has an opinionated model with secrets, and it would only be for a bootstrap condition, right? You'd be putting in something into the kubelet code that exists only for bootstrapping in a very particular way, right? So we have the main reason that I personally want to see this not as an external process is because we've had conflicts with kubelet authorization, and so when our checkpointer uses the kubelet's API in order to
get the manifest.
And the kublets can do just authentication where it says, if you have credentials, then I'll let you through to any of my APIs. But they also have the ability to do authorization. So you can say Prometheus can read the health endpoint, but it can't other processes, but it can't exec into a pod. That authorization requires an API server to be alive. So there's, again, the bootstrapping problem of the kubelet will ask the API server for authorization decisions, but if there's no API server, then the checkpointer can't access that API. I don't know if that is, so the idea of baking checkpointing into the kubelet is something that would help us get around this, but I don't know if there are alternative mechanisms that we can discuss with SIG-auth or something like that. But that was a concern that I saw.
So go ahead.
I know that Dawn had said we had coerced her in a corner that she would be willing to entertain this for the 1.8 cycle. But I do think we probably then need to do a formal proposal and have all our I's dotted and T's crossed for how the bootstrapping sequence would go. And this would basically mean that there'd be a lot less opinions, right? It would be distilling how self-hosting and bootstrapping would occur.
Yeah. I mean, so fundamentally, the problem that we're trying to solve in my mind is that the kubelet should be able to recover its local state in the absence of an API server.
Well, local state for self-hosted, because I was thinking about this too. You can't really recover, and you don't want to, for other workloads in the non-self-hosted case, right? So if you actually had workloads, this is a standard kubelet, not a master, you don't necessarily want to recover because the time delay from when you have rebooted or whatnot, you'd want to check in with the API server before you try to recover. You absolutely need to do that.
I don't know that that's actually, so let's consider the case right now today. The kubelet, if it is restarted itself, is going to recover as much state as it can from the container runtime. So it's going to look at Docker and be like, oh, look, there's a bunch of these pods and they're supposed to keep running. So I'm going to make sure that they
Sure. Yep.
So the only difference is we're saying that that local state, it's essentially, its checkpointing right now is Docker's state. But during a reboot, that state is now gone. And so it has nothing that it can recover. So in my mind, it's not that different from restarting the kubelet to restarting the server. It's just that the state that we're relying on isn't Docker anymore. The state that we're relying on is...
Here's where I disagree, because you don't know if it's a controlled reboot or not. And the only way you can do that, you don't know if you're in maintenance mode, right? So the only way to do that is to check back in with the API server. So if you start rerunning workloads, it may have already recovered from a failure condition, right? And you could potentially have, like, there can be only one conditions, right? So if you recovered and started working and brought these things back up online before checking into the API server to say, is it okay for me to do that? What type of scenario am I in? Am I in a maintenance mode and I need to recover my state? Or am I in this, like, it was a catastrophic failure condition, in which case something else recovered on my system, and now there can be only one pod is now alive somewhere else, right?
I get the concern, but why is a reboot the heuristic of that becomes unsafe versus anything else happening on the host? Like, why is the fact that Docker has lost state the heuristic that says, oh, well, I shouldn't recover state anymore?
I think the assumption might be that if Docker is still running things and the kubelet's restarted, the time delta between when it checked in with the API server is probably less, right? Because you could power off a machine, wait 2 days, turn it back on, and presumably those workloads are now running somewhere else if your cluster is functioning properly. And the kubelet has no notion of how long it's been, right?
So
it may not have that notion today either, right?
We probably should, honestly.
Yes, but it probably should check Docker and say, have these, how long have things been running for? And have some sort of timeout there.
I mean, the other systems actually have claim life cycles. So they have time intervals where they can go with headless, right? And if you haven't checked in within that life cycle, you're basically saying, all bets are off, I'm going to nuke everything on this machine.
So we could do, like, if we, just hypothetically, if we were to try and move this into the kubelet, it could be something like restrict the workloads that we do this for, so something like an annotation on the workloads. And then additionally, start having concepts of, when does this actually, how long is this data actually valid for?
Yes, I like both of those.
That's what I was going to suggest, is why don't we just stick like an alpha annotation on the control plane manifests, and the kubelet code can say, if there's this alpha annotation, I will checkpoint the manifests, and for everybody else, I won't. And that basically keeps the system behavior the same in all cases except for the control plane things that we know we want to checkpoint. Everything else, like maybe we want to checkpoint, and users can optionally add the annotation themselves, but the control plane, we sort of know we want to checkpoint. Right? And that makes it an opt-in for checkpointing.
And like, so I heavily would prefer that this is implemented in the kubelet, because doing it external just becomes you've seen the checkpointer, it's pretty gross. It's just shuffling files around on disk.
Right.
So, there's some complexities here around, is it okay if we checkpoint secrets or not? Or things like, we just throwing files on disk and that the kubelet reads those and then tries to persist them to the API, which in prior discussions, people are very unhappy about that kind of direction of persistence. So there's a lot of stuff that we have to work out. But if we were going through, like, if kubeadmin is going to go down the route of kind of rewriting their own style of checkpointing, and we have to continue supporting a different style of checkpointing, and then no one's working on the kubelet, I feel like we're all going to lose out instead of just biting the bullet, maybe just getting a proposal in place at least. we've known this has been something we want for a while.
I think Robert alleviated my biggest concern, which is that we can't checkpoint and recover everything, right? And so long as we have the annotation, and that I think makes a pathway towards getting it in the main line a lot easier, right?
Yes, and we make it an alpha annotation. We turn it, maybe off by default for a release cycle. We can turn it on for kubeadmin so that we can start using it. But then it doesn't sort of impact everybody across the board. And if it's something that's really great, we can promote it from annotation to a field later, right? And make it part of the official object.
That sounds really good to me. And I mean, just a broader statement. I feel like we should work together and not independently in silos. And I feel like we should also leverage the experience of others who've done this before, like just as level setting.
I think one thing we didn't agree on, to step back a couple bits, was Luke's proposal for having a consistent experience with self-hosted on one node versus, maybe I lost my connection while I was trying to go upstairs to get power. But I didn't hear us come to a conclusion on whether we were aiming to support the same experience on one versus many master nodes. I think Tim was dissenting on that. Maybe we can alleviate those concerns by saying we aren't going to shoot for the moon for 1.8, and maybe
if we
that's
push
the
it,
eventual goal.
Yeah, if we push it in the main line, and we have this mechanism by which to opt in for the masters, I'm not opposed to it, because that way it's standard, right? Everyone's going to agree upon the same practices, and right. I'm okay with that. But there's going to be some opinionated thing about tokens that we're going to have to deal with, right?
Yeah, and I think at a high level, one of the goals of cluster lifecycle and what we're pushing with kubeadmin is to try and standardize some of these processes so that everybody isn't re-implementing it their own way, that the core mainline code has the features we need for bootstrapping. Right? I think this is one of those features that people have always sort of known we needed, and nobody's really figured out how to put in yet.
So would it be reasonable to say, let's try and get the new update strategy in by 1.8, and if we don't, then single master isn't supported with self-hosted, if that falls through?
I think that's a reasonable thing to say for this cycle, right? I think there's going to be some pushback from the node team, and we're going to have to deal with the funsies there. So, but what I'd like to do is, Lucas has a checklist for self-hosted, right? And there's an issue, parent issue for that. If we can modify that one, and I have a child melting down in the background, so.
No problem.
Summer vacation, it's killing me. If we can modify that checklist to include portions of checkpointing that we want to have in place, I think we can execute against those pieces.
Yeah, I think one important thing to come out of this discussion is what we need to ask other people for. And I've heard two things so far. One is we need the node team to agree to some sort of checkpointing. I think we need to give them a proposal soon. Dawn verbally agreed during the leadership offsite, effectively saying if we did the work, she would let it in. And the second thing is to ask SIG apps to modify the daemon set upgrade behavior. So I think identifying those things early and asking our dependent SIGs to implement those for us is very important.
Sounds good.
And so is like the update strategy thing something that we need to just say someone else needs to work on, or if we have time to pick that up, that they would be like, we just need to get it on the roadmap for review?
I think they need to agree that it is a reasonable thing to implement. And then after that, we can put it on their roadmap and ask them nicely to do it, or ask them for review cycles, right? If we just do it but haven't gotten agreement for at least review cycles, then there's a high risk it's not going to make it.
So we'll poke Mike. That's the answer?
Well, no, it's Eric Toon.
Oh, okay.
Yeah, Mike no longer owns daemon sets, unfortunately. That would make it a lot easier. Eric and Janet from the Google side.
And then one other thing I wanted to ask about, and this kind of depending on how far we get with kubelet checkpointing, what are people's thoughts about moving the checkpointer into incubator, or do we just kind of let it sit in bootcube? Like, would kubeadmin start using it or not?
I think they discussed last week moving it into the kubeadmin repo. Is that right, Tim?
But what, didn't we just decide we were going to write a proposal and try to get it in, at least the checkpointer into the kubelet?
Yes, I think Aaron was talking about if that doesn't work.
Well, we'll make it work.
Yeah, let's make.
I mean, I don't want to have Kobayashi Marus. I want us to like go the right way, because this has been on your radar for so long, and we just need to pound it through, right? At some point, we need to just make this happen. So.
Cool. Sounds good to me.
Oh, I guess one other thing to mention is we may only need that annotation on specific types of manifests, especially if we're running everything as daemon sets. We may not need to add support for checkpointing lots of different object types, especially in the earlier versions.
Would you ever checkpoint anything except for a pod?
Well, I guess that's true. Yeah, you're not going to checkpoint the API object. You're going to checkpoint what the kubelet knows about. Sorry.
And then, does anyone have problems conceptually with checkpointing secrets? Because that's kind of a non-starter for us. And like my only initial thoughts would be something like, maybe encrypt them with like the kubelet key material or something, because if it already exists and it can retrieve it from the API anyway, and you're worried about it being at rest or something like that. But for us, we pretty much require that we would be able to checkpoint that data.
I don't, but we're going to start to get into that opinionated portion.
Well, I mean, the litmus test for me is, can you reboot a single master? I mean, if you lose all your secrets when you reboot a single master, then we have to checkpoint secrets, right? Unless I'm misunderstanding it.
Unless you expect them to be on the host itself, and that's part of your on-host contract, which we're trying not to do, and I don't see that big of a difference between checkpointing the data on the host or providing it on the host. I do see the difference in terms of like retrieving it from the API, but
a lot of the concerns around secrets in the API or putting them in the API is people wanting them on disk anyway. So I think that the opposition there is, should these secrets be in the API, versus should we write them to disk?
Yeah, it's interesting because one of the security guys I talked to here said he preferred to have them on disk because it was easier to secure access to the local disk than to the API.
Yeah. That's Jordan's common statement too.
Okay, well, we're about out of time. I don't know if we're going to get a conclusion on that point.
Is it, Aaron, is it okay to punt on that for now and push forward, like start creating a proposal without specifying that detail at this point? To at least move the checkpointer forward, or is the checkpointer not useful in the kubelet if it doesn't also do secrets?
I mean, from our perspective, it wouldn't be, like, we wouldn't be able to use it, which would be hugely unfortunate. So if we could at least have that as part of the discussion, and maybe from that discussion it comes like, absolutely not, we're not going to allow this, or it's an opt-in or something of that sort. Yeah.
Okay, excellent. I just want to make sure we didn't push forward without that, and then you guys couldn't use anything, right? I mean, that would be a bad scenario. Back to the consolidation and alignment bits. We have a minute and a half left. We need some owners for some actions going forward here. So I haven't written down all the actions explicitly. We need to talk to the SIG apps team. We need to create a proposal for checkpointing for the node team. What else am I missing?
We need to update the checklist for kubeadm 127.
Yes. All right, I will talk to the SIG app team about daemon set upgrades.
And then we potentially will have some cycles to do the work on this stuff. I don't want to volunteer anyone until I've actually spoken to them yet. So, but this is all stuff we really, really want, so we're more than happy to dedicate some time to it. Tim, was the kubelet proposal itself something that you were potentially going to take on?
I can work with you guys because you have opinions on how different. I mean, I think what we should probably do before even just have a single document as a template, and we can modify portions of it together, and then maybe work within the SIG before we promote it up and talk to Dawn, just so that we're all on the same page. Does that seem reasonable?
Yeah. That's sorry. That's what I meant by proposal. It wasn't like actually propose it. Was to create the proposal so we can agree before we propose it. Right. We need to agree first before we start talking to the other SIGs.
Sounds good.
But we need to create that skeleton document, and we need to have someone sort of fill it in with default information before we all jump on top of it. So someone needs to create the doc and start filling it in, and that's what we need. We need now. And then after that, we can start together.
I can create the doc and fill in the pieces of the skeleton, but I would like someone from CoreOS to help put in the pieces that they want to.
Absolutely. Yeah.
Probably butchered your GitHub handle there. Sorry.
Eric just whispered that he would help on that as well.
Yay! Thanks, Eric.
No problem. And then the third thing, Tim, was third action. I've already forgotten.
Update 127. I'll put the paste in there.
Cool. Well, thank you, everyone. This feels like it was a very constructive meeting. I guess the only problem that I feel like we have is like a small intersection of people between meetings in these weekly meetings, because it's hard to drive consensus forwards when you have like a random subset of people in each meeting. But hopefully we can, hopefully people who were here today can try and come next week as well, and make sure that we add people who were missing, so we can get faster to consensus and driving this forward.
Yes.
Cool.
Totally agree.
Anything else? Awesome. Thanks so much, everyone.
Thanks.
Have a great weekend. Bye.
Thank you. Bye.